This is homework 23, recursive rules. It's asking us to define the explicit and recursive rule. So our explicit rule, remember, was a sub n equals our first term plus our common difference times n minus 1. You also see it like this, and you can also see it, and that technically, if we're going to do it in that would mean the first term plus, and you can have the d on the back side too. It doesn't matter if the d is in front or it's in the back. So the explicit rule will take you takes you to a specific term in the sequence. So we can go exactly to the 10th term or to the 15th term or whatever term you want to do. The recursive rule is a sub n equals a sub n minus 1 plus our common difference d. So the a sub n minus 1 here means, all that means is our previous term. Okay, a sub n means the term we're on. A sub n plus 1 means our next term, and a sub n minus 1 would be the previous term. So think of it like as three numbers in a row. A sub n would be the number you're on, a sub n minus 1 would be the number in front of your number, a sub n plus 1 would be the number after your number. So that's how it is. Where you are, where you were, where you're going. And so the recursive rule will take you to the next term in the sequence. So we're at the first 5 terms of the sequence. It's saying a sub 0, that would mean the term in front of this, that would be right there. So that's 4. And our common difference, because of this equation, right? That means our common difference is what? If this is our, see where that d is? The d is the last number out there. Remember, common difference was the d. So this is our common difference, is negative 2 here. That's what that's saying. So what's 4 minus 2? 2, 0, negative 2, negative 4, negative 6. Same thing here. This says the first term is 3. And okay, so this isn't linear. This isn't linear. This is or arithmetic, I guess. This would be a geometric sequence. We'll learn about that later. But so that's just saying take your previous term, right? A sub n minus 1 means your previous term, and we're multiplying it by 5. So that would be 15. 15 times 5 would be 75. 75 times 5, what would that be? 425? Is that right? 150 or 675? No, 75 times 5, 425. 75 times 2 is 150, so 75 times 4 would be 300. 75 times 5 would be 375. There we go. And then 375 times 5 is 25, 37, 15, 1875. This is saying our first term is -1. Then we want to take our previous term, and what are we doing to it? We're going to square it and then add 3. So the next term would be -1 squared plus 3. So that would be 1 plus 3, which would be 4. And then we're going to say, okay, to get to our next term, we're going to take our previous term, which is 4, square it, and add 3. 4 squared is 16 plus 3 is 18. Next one, we're going to take our previous term, which is 18, and square it and add 3. 18 squared, you guys can do all that math. So you can do that. And then add 3 to it. And then take that number, square it, add 3 to it, and you'll get this other number. Read an explicit rule and recursive rule for the sequence. Remember that D is the common difference of an arithmetic sequence and R is the common ratio for a geometric sequence. So, good, we're doing all. We don't learn geometric yet, so we'll hold off for that. So, our explicit rule, right? A sub n equals a sub 1 plus 5 times n minus 1. So that'd be 1 plus 5n minus 5. So this would be a sub n equals 5n, and -5 and 1 make -4. Our recursive rule is just a sub n equals a sub n minus 1 plus our common difference, plus 5. Those are really easy to make. You don't have to do any work. This explicit rule would be a sub n equals 25 plus -5 times n minus 1. So that's 25 minus 5n plus 5. So this is a sub n equals -5n, and 25 and 5 make 30. And our recursive rule is easy, right? It's just a sub n minus 1 plus our common difference, so that's minus 5. Our next one, a sub n equals 0 plus -2 times n minus 1. So that's -2n plus 2. We don't have to add anymore, so a sub n equals -2n plus 2. And then our recursive rule would be a sub n equals a sub n minus 1, and we're subtracting 2 each time, so minus 2. Our last one, a sub n equals 4 plus 10 times the quantity n minus 1. 4 plus 10n minus 10. So a sub n equals 10n, and 4 minus 10 makes -6. So our recursive rule is a sub n equals a sub n minus 1, and our common difference is 10, so plus 10. Write a recursive rule for the sequence. So what's happening here? We're adding by 5. So this would be a sub n equals a sub n minus 1 plus 5. It's that easy. We're adding by actually we're not adding, we're multiplying by 4 here. And just so that we can do this, this is a geometric sequence. Geometric sequences, the general rule is a sub n equals our common ratio r, which is what that number is. This is r equals 4. When we multiply, we call it a common ratio. R times a sub n minus 1, so it's real similar. So that's just a sub n equals 4 times a sub n minus 1. And this one, 12 to 3, what is that? Going down by 9. 3 minus 9 is -6. -6 minus 9 is -15. Alright. So our common difference is negative 9. So a sub n equals our first term is 12. So 12 plus negative 9, negative 9 times n minus 1. So this is 12 minus 9n plus 9, 12 and 9. So negative 9n, 12 and 9 makes 21, so plus 21. So there's our rule. Oh shoot, I didn't do the recursive rule. The recursive rule is just minus 9, so a sub n equals a sub n minus 1 minus 9. There's our recursive rule. We're just subtracting 9 from the next term. Suppose you buy a $300 television set on layaway by making a down payment of $60 and then paying $16 per month. Write a recursive rule for the total amount of money paid on the television set in n months. So we're write a recursive rule in the amount of payment in the nth month. How much will you have left to pay on the television after 9th month? I don't know if this is a recursive problem or not. This is like y equals 16m for months per month plus 60, and we want to know, you know, when that's going to be 300. So and when it's going to be in the 9th month, how much we'll pay, so that we just plug in a 9 here is all that is. So the 9th month, 16 times 9 plus 60, 16 times 9 is, what is that, 54, so 9, 1,444, plus 60, so that's 204. So left to pay after the 9th month would be 300 minus 204, so it would be 96 bucks. What are the first 5 terms of the sequence? So the first term is 3. This would be the next term equals the term you're on minus 4. So the first term is 3, so it can't be this one or that one, because it's saying the first term is 3. And then we need to subtract 4 to get to the next, our next term equals the term we're on minus 4. So that would be 3 minus 4 would be negative 1, and then negative 1 minus 4 would be negative 5, so it's C. The first 5 terms of the sequence are here, which gives us the nth term of the sequence, so that's equals a sub 1 plus common difference times n minus 1. So that's going to be 14 plus, what's our common difference? Looks like we're adding 3 each time. So 3 times n minus 1. So that's 14 plus 3n minus 3. So a sub n equals 3n, and 14 minus 3 makes 11. And that's the exact same as B here. Doesn't matter which order they in. I write them with our variables in front. C, which is a recursive rule for the sequence. What are we doing? looks like we're adding 3. Oh, no we're not. 2 to 5. 5 to, so we're multiplying here. What are we doing? So this is saying, so all these, well, this says our first term is 2, right? So if our first term is 2, then we can get rid of B and D because they say our first term is 3. And this would be saying we'd take our previous term, to get to our next term, we'd take our previous term and add 1. So that would be 2 plus 1 would be 3. So that's not right. This one's saying we take our previous term, multiply it by 2 and add 1. So 2, right? That would be, so if we want to know where say, pretend we don't know where 5 is. So we want this one. So we pretend we know what 2 is. So that would be our previous term. Multiply it by 2. 2 times 2 makes 4. Plus 1 makes 5. So then pretend you're at 11, but you don't know where it is, but you know that 2 and 5 are there. So then previous term would be 5. 5 times 2 makes 10. 10 plus 1 makes 11. So it's this one. And that's not a linear or arithmetic sequence here. Which sequence is produced from the definition? Okay. So this is just saying our first term is -3, so all of them are right there. That's all good. And then we're going to take, to get to our, so then pretend we want to know what this term is, but we only know that this is our term before was -3, right? So we're going to take this one and plug in a -3 there. So 2 times -3 minus 13. That's -6 minus 13 would be -19. So that's A. E, the graph shows the first 5 terms of an arithmetic sequence whose domain is the positive integer, so this is our domain. Which is the definition of the sequence. So when we substitute in a 1, we should get out an 8, right? When we substitute in a 2, we should get out a 6, right? Because this is the 0.18. 2, 6, 3, 4, and so on, right? So we ought to be able to substitute in a 1 into any of these because I can do it quickly. I see that looks like B is going to be the answer, so let's try this one. Let's plug it into this one. So plug in any of these numbers, right? So let's try 2 to 6 right here. If we substitute in a 2 for n, we should get a 6 out. So T of 2 equals 8 minus 2 times 2. So that's 8 minus 4. 8 minus 4 is 4. Ooh, that's not right. Ooh, let's try D then. Try this one. T of 2 is 10 minus 2 times 2. So that would be 10 minus 4, which is 6. So it's D. Look at that. I was wrong the first time.